collide it with the two objects. And then next time we're using the same approach, making it as a way of creating a form finding. And then up here, I'm going to give you a couple of other components that you might want to use later on. For example, we are going to use wind, and also entwine. So two different components in order to see how that's going to affect our simulation. So let's just start getting back to our, so everybody save your file. Let's go back here, and then what I'm going to do is that I'm going to using the same a little bit different mesh here. So I'm going to delete everything that I have. And the first one I want to do is that I'm going to use a rectangle. So I'm going to use the rectangle. And then within that rectangle, I'm going to create two, going to add the X and Y value. So for X and Y, I'm going to use 50. And we are not changing the plane. We're going to keep the plane wherever it is. So that's going to be my rectangle right there. Now, this rectangle is right on the surface, on the ground. And I want to move it up a little bit because I want to use that collision later on. So what I'm going to do is that I'm going to use like a move tool. Connecting the geometry using this unit Z. And for the unit Z, we're going to give a value of 50. All right. Now, let's create our mesh using the mesh plane. And then mesh plane, this time for a boundary, we are using this rectangle that we create, the one that we move it 50 unit up. And then for the W and H value, we're going to use value of 50. Okay. Once we have that, then we are using, our surface is ready. Now we need to set up the goals for creating different forces on it. So one of them is going to be the same thing. We are creating this basically using the web edge, Weaverbird edges to get the edges out of this. So we're going to use that. Our geometry is going to be that mesh. It's not changing. And if you look at it, if I zoom in here, you see that now there are more elements on that surface compared to the previous example. Okay. Now, once we have that, we can use the same methods that we used last time. We're going to use the length line, which is a component from Kangaroo2, and then connecting the edges to the line here. Do the same thing that we did last time for the length of the line. Multiply that with the value of 1, and we can change the value later on if you want. And then we connect that into the length. We keep the strength as is. Now, in addition to the weight of this time I'm going to add another variables, which is the wind. So let's see if this is like something outside, and then we want to see how the wind is going to affect this. So we are going to use wind, and for the wind we have two inputs. One of them is the mesh that we created, and the other one is the direction. So right now the direction is in a x direction. So we're going to keep it as in x direction, but we're going to reduce the amount of forces. So let's connect the mesh to the input of mesh, and then for the vector data, for the wind direction, we're going to use the x unit, and then this time we're going to put the value of 0.1. Okay, something very subtle. We don't want to move the whole thing to one direction. Okay. Now, what else we need to do? If we simulate this is going to be flowing away as it falls. We need the anchor point to hold it up straight. So we bring the anchor point. And for the anchor points, what we need a mesh corner. So we're going to use the mesh corners and connecting the mesh and connecting that into our anchor. All right. So that's the part for basically defining the same thing that we did. Now, if you recall from the example, we have two spheres in the middle of this that we wanted to be collided with, right? So we need a couple of things here. One is that we are looking for defining this surface that is going to be collided with another elements. So we need to deconstruct all the elements on the surface, which is all the points or the vertices, to become an elements that will be simulated when this collision happens. So we are going to use we are using the solid point cloud. And the other one that we are going to use is the sphere collides. So two components here, right? For the first one, which is the sphere collide, what we need is a series of like a vertices that is existed on this mesh. So what I'm going to do is that I'm going to deconstruct this mesh that I have, and using the vertices that I got, so as an input to this one. And for the R value, for the radius value, I'm going to give a value of 1.95. All right. Now, we know that these points, in addition to be part of the simulation, they have to have a loads on them, right? So we need to bring loads on this as well. So we're going to use the load, put the loads here, and then doing the same thing. The vertices goes here, and direction will be z value, and the value for that it's going to be 0.1. And this time I'm going to use reverse direction for the vector data instead of using the negative value. And then connecting that into my forces vector. So basically the z value and then reversing the direction of that vector data. And the points is going to be the same. Now we're going to looking at the points that is going to be colliding with another elements, another objects, the solid that is going to be the part of the collision. So I'm going to connect the vertices again here to the point. So this point that is it requires sets of points and also requires an object, a sphere that we're looking for. Now, for the sphere, we first need to create a couple of like points. So So the first point is 20, 40, 15. And the second point will be at the location of 10, 10, 10. So 20, 40, 15. That's one point. And the other one was 10, 10, 10. All right. Now that I have that, I can create my sphere here. So I'm going to use the sphere. And for the base, I'm going to use these 2 points and connecting them using shift so that I can give a 2 input to it. And then for the radius, I'm going to give the radius of 10. Okay. Now you have to have the surface itself and then 2 spheres on that 2 location. And then we're going to connect that into the solid. Now that the goals are set, it's actually there is one thing that is missing, and that is the show. So we want to see the end result of the simulation as well. So we're going to use show. And then using this mesh itself to connect that. So this time, instead of using a merger, what I'm going to use in order to combine all these goals together, I'm going to use what it's called the entwine. So entwine is very similar to merge, but it's basically help us manage the data much more better. Because eventually what we are going to do is that we're going to get the export out of this data. And then last time you see that I was digging where the mesh is located. But this time by using this like a format, I can actually manage where each of these data goes and the outcome I have more like a flexibility in order to get the data out. So for this one, I'm going to connect the show to the first group. And then the rest of them, all of them will be connecting to the second point. So all the other goals that I have, all of them connected to 0, 1. Okay. Once I have them ready, the next step here is just connecting them into to bouncy solver to see the end outcome of this. So I'm going to use the bouncy solver. We need the bottom to reset everything, right? And we also need a Boolean for true and false. A Boolean toggle here, connected here. The reset goes to the reset. And then for the iteration, we're going to use 1 to see much smoother like a transition in terms of how the surface is going to look like. And then I'm going to connect the goals into here. And I'm going to say true, and then let the simulation start.